G'day everybody and welcome back. Today what I want to do, or what I am doing should I say, is I'm in the process of cutting out more PCBs because I want to get this amplifier built. So I want to get the driver boards, laid out, decide on component choice, values, particularly component choice, not so much values for today because we're just trying to work out where everything's going to be laid. This is the last part of this amplifier that I can make a PCB up for. So going back from here, we've got to breadboard everything because, well, apart from a very, very basic Class A preamp stage, very basic, I don't have a front-end design for this. I've got a design here and I've got a few other designs that I want to play around with, so that's all going to get done on breadboard. But as I've said, I want a powered output stage that's capable of being biased up and all that. You know, it's just needs a signal to produce power. It'll just effectively be a large current amplifier. I wanted the power supply, not that I'm going to be using the power supply for anything other than running the output stage when I do want to run it. But yeah, so this is the last board that we're going to get done just without having to, remodel stuff and re-engineer it. So I'm going to go finish cutting these and then I'll come back and we'll start getting it all laid out. I'll draw it out on a piece of paper in a square the same size as this, and then that'll help me and you guys to envision what it's going to look like. Alright, so I've been having a little bit of a think about component selection, like I said, because I'm going to lay out the driver boards. And I've decided to go with 100 nano and 47 mic for these values. I had 470 and 220, but that's a bit excessive, and also it's going to take up too much space. Yes, these ones are red. Mylar 100 nano. That's how much space that's going to take, which is still a bit of space when you think about it on two boards. So, but that's still sufficient capacitance for what I'm trying to do. The other thing I'm going to do is I'm going to remove this that I added in, this extra capacitor, two capacitors, a film and an electro. Same thing again, I don't think it's necessary. Would it help? Yeah, of course, but it's not necessary. I don't think there's going to be an audible difference like less hiss or something like that, because I already built this amp, like I said, years ago, and I didn't, what have I done? No, that's right. I didn't have a capacitor between the rails here or from rail to ground. The driver section was just running off the main cap bank. The only thing that had its own cap bank was the preamp stage. So I'm just going to do that because that's already more than what it had. It's bypassed each rail to ground with 100 nano film and a 47 micro electro. The 100 nano poly and the 4.7 mic between the bases for the bias network stability, that's still staying there, but I've just changed those values and removed that. Everything else that's on here, I think I'm going to leave. The one thing I'm considering removing is the 10 ohm resistors. I'm going to have a little bit of a think about this now. That's basically what I'm deciding on now. So I added them in there to act as a filter with the capacitor going to the rail, you know, but is it necessary is what I'm asking myself now. What I'm basically doing is looking at everything and trying to decide whether I want it because it's actually going to be beneficial or is it just going to waste space. I know this doesn't apply to this, but something else I'm going to do is make this 1 a 2, because I do remember when I built this amp, I did start with a really high resistance. I moved it down and it could have been around 150 or something like that. K. I don't know if it was in between 47 and 100. So, you know, just for now, that's going to be in that ballpark. Let me have a think about these 10 ohm resistors, and then I think what I'll do is, once I've decided on that, I'll draw this out because I'm happy with it. You know what, I'm going to leave it. I don't have current sources here. Not that you usually do for a driver stage, buffer stage, whatever, but because it is a triple Darlington, this smaller section here is, how to explain it, it's got higher impedance on its inputs, it's more sensitive to stuff. I think it helps. I mean, it definitely helps. I think it's going to benefit from having it. So, you know, they could even be higher values, like 22, maybe 47 ohms. I'm just going to leave 10 for now, and the diodes. So I'll start mocking this up now. I know this is completely unrelated, but I was just about, well, I just started that, and I was having a look at some different pages in here, and it got me thinking about the input section, because I don't like doing all this. If I hear like hiss or something that's input related, then I might filter the input a little bit with a circuit more similar to this, but usually I go with something more simple like this. But what I did fail to add was a resistor here. Sorry, here. How am I going to draw that in? You know, I'll just do it like this. Make it 100k. Just as a bleeder resistor for this capacitor, so that this is a closed loop here. That's all. I know it's not a massive thing, but I have actually destroyed sound cards and random devices just literally plugging in and unplugging amplifiers whilst they were turned on, and you know, just that little bit of DC that had built up on either the tip or ring of, say, a 3.5mm plug went and fried silicon. So given that I've actually experienced it with, okay, they were cheap rubbish amps and they probably didn't have a proper input stage and that's what happened, but products that were already made, I don't want to emit that. So I just thought I'd point that out. I also hate to see someone else destroy their sound card or something that's driving a signal in, because DC can build up on the capacitor and then they can unplug it and plug it back in and put a little spike into their sound card and screw it up. That would not be good. Alright. I just noticed something else absolutely hilarious as I started trying to work out where I want to put these capacitors. I just got twice as many capacitors out as what I needed. That pile I showed you was 8 of each. I only need 4 of each for 2 amps. I don't know what I was thinking. Wait a minute. Yeah, 4 of each. Anyway, if anyone's taking notes, I must be the most confusing person. My apologies. Alright, I've mocked up something on paper. It's got to be stretched out more, so where that resistor, capacitor, electrolytic capacitor and diode is, it's not going to fit in that space, but we have all this space here. That's the whole reason I didn't erase it and move it, because I can see it with my own eyes that I have more space there. So when I make the board up, I'll just, you know what I mean. I couldn't be bothered drawing it twice, to cut a long story short. Anyway, I've left everything I want on here, and I've left provisionments for collector to base, Miller capacitors, the extra resistor that I was discussing adding for cross distortion, not crossover distortion. What else? I've split the 820 ohm resistor up into two 430s with a center tap point in case I want to do something with the output stage. Now this brings me to something I've just realized. Let me just pause and go get these boards. The boards I made for the output stage, when I made them, I forgot about leaving provisionments for millicapacitors on the drivers, and I also forgot, there's something else I'm forgetting. It came to mind and it's left my mind again. Oh man. Oh yes, the resistors. So I was meant to put, a place on here to, I'll just show you on the schematic. These two resistors here that go from the bases of these two transistors. You know what I've just realised? I guess the 2.2 ohms wouldn't matter. I was just thinking I'd rather have this node here attached to here, not before the resistor. Well, I guess I will now, because I have to add it obviously. And when I add it, it'll be just tacked onto the transistor's base, won't it? So it effectively will be now. Whoops. So what I'll have to do is, well, let's see. Actually, no, you know what? We've got base resistors. It's got to go before the base resistors. What am I saying? I'm not thinking. Never mind. Yeah. It's got to, just forget about that line I just drew, because it's got to, these resistors have got to go between the bases of all the output devices, and because they all have their own base resistor, the node where they're all summed at is that node there and that node there. So just forget those two lines I drew. They will never be used. I still need a spot to put them on the board. I mean, they're going to have to go between here and here. So yeah, you know what? I think what I'll do is, after I've mounted everything onto the board, I'll come up with an idea, like some standoffs or something little. Let me go get an example. I got a whole bucket of these things, both in chrome and silver plated. So just random stuff I got at JCar warehouse clearances. So I could take these, make a hole in the board, press fit that in, bend it over at the bottom so it can't come back out, and put, a standoff there, a standoff in the middle, a standoff there, and run a little bit of solid wire from the base to the standoff, the emitter to the standoff, the other emitter to the standoff, and then my two power resistors will go between the standoffs to the middle standoff, which will be the point that would get connected via a wire to this point here on that board. So yeah, I forgot, but there's a workaround. So it's all right. Like, I can still build the amps, and sorry if that was a bit loud. And they will still be securely mounted to the board at least. So, and the same thing for if I do need some sort of millicapacitance on the drivers, which I doubt it'll be probably getting done further back. There's plenty of space to tack a little ceramic capacitor across there. So although I left it out, the only thing that is really going to take a bit of screwing around is adding those two resistors, because I've got to put standoffs. So it's not too bad. It is what it is. Right. So let's discuss this. Basically, I haven't put component values on here, but we'll just talk about it quickly. I'll just unlock that focus and relock it so it's nice and clear. There we go. All right, so BC550s. You know what? I can't remember what I'm using. No, 546s, 556s. Two 430 ohm resistors with that summing node in the middle. Our diodes, remember I said before that these 4 diodes would be mounted right next to the base? This is what I was talking about. In reality, it would be even closer than this. I'll get it really close on the board, you know. And the diode will stand up right next to the transistor. We've got our 47 mic and 100 nano capacitors here. 4007 diodes and 10 ohm resistors. This is where the DC comes in. 0 volts, negative, positive. 33k resistors, 4 of them. And oh my god, that would be an interesting amplifier with some pretty crazy offset issues. I know it's not perfect, but you get the point. Right, 4 500 ohm pots to set the offset. And then between the bases of the NPN and PNP side for each of the 2 channels, we've got the spot for the cross distortion resistor, 100 nano cap, 4.7 mic cap, and a 4007 diode. These diodes are UF 4007s. These are 1N 4007s. And last but not least, like I said before, spots for Miller compensation capacitors, if any or all of them even need to be used. So I'm going to now get this onto PCB and then we'll etch the boards. The other thing I want to get done tonight, other than just getting these 2 boards etched up, I want to get all the holes drilled. Now, I've had a bit of a think about this. Let me just take you guys over to where the boards are. Don't worry, none of those cheap capacitors are going. See, all the cheap shit that I've ordered that turned out, you know, I've done review videos on this, you know, months ago, and it's still separate to all my stock. You know, when I get stuff, you know, all the stuff that I've bought recently, this entire drawer's for stuff that's recently acquired, you know, but everything in here, I don't know if you can tell just looking at the components, they're all legit components, you know. So that's why they're in my drawers, and I've also tested everything too, so I know that they're you know, you've got valid breakdown voltages, capacitance ratings, ESR, all that sort of stuff. Some things I've even gone further and had a look at more specs, but anyway, I keep all the rubbish separate. That's not there to go in these amps, it's just there because I was moving stuff around in here. So the other thing I wanted to get done tonight, after I tried making up those SMD boards for the differential amplifiers, I've decided no more drilling holes unless it's absolutely necessary. That's just, it's not fun. I'll leave it at that. I want to build a little miniature drill press, either build or buy one. I'm not too fussed. I just want it for drilling small bits of hard metal sometimes and PCBs and stuff like that, you know. Anyway, I'm going to try and avoid drilling holes as much as I can in PCBs. So this was never going to have holes drilled in it anyway. It was always going to be mounted like this. This is, you can probably tell that I designed it to be like that. Obviously the capacitor bank will have holes for the capacitors. Obviously the output devices and drivers will have holes because, you know, I don't want the risk of solder cracking because this is, you know, a bit of weight and it's just not, you know what I'm trying to say. It's not an advisable thing to do, to hang a board that's got inductors and power resistors and wires hanging off of a whole load of devices on a heatsink. You just don't do that. So I'm going to, well, you know, you need to have the board supported, but even if you have it supported, which I will build supports for these boards, you still don't want it just sitting on top, you know, like without the pin going through the actual board. When you're working with smaller stuff like that, I mean, a couple of these components like that, for example, should go through holes, but, you know, like most of this stuff's really small, you can get away with it, it's fine, but you got a couple of things to think about here. One is the weight and how much it's going to vibrate and move around when you move the device, like the weight of the PCB. The other thing you got to think about is this is a heatsink full of transistors. It gets hot, so it's going to thermally cycle. That could stress out the solder joints and they could form cracks. You, again, don't want some sort of downwards force on it if it's only just you don't want downward force on it anyway, but you certainly don't if it's just soldered from the top. You know what I mean? So I'm going to drill holes for these boards and these boards, but everything else like this and the boards I'm making now and the preamplifier boards, they're all going to just be mounted, sorry about that, mounted from the top. So yeah, I'm going to go get this done now and I'll come back when I'm ready to etch. Something just occurred to me. It didn't occur to me until now to mention it, because in my mind I was already, how do you say this, complacent with the idea. I'd already decided upon this. I changed my mind earlier on, and anyway, I forgot to mention this, but I just realized looking at these two boards and this packet here that you guys might be a bit confused, because this was supposed to be the driver boards. Well, let me explain. When I looked at this earlier on today, I realized that basically 2 channels for 1 amp would fit on a board this big. So, I could probably even squeeze it onto that if I tried. But anyway, what I figured was, because I want the preamp boards separate and I want to play around with different things, and it's going to be a smaller circuit most likely and a longer circuit, because it's going to be transistor pairs and then current sources and sinks on top of them, so I can use the length of this board. Also, there's 4 here, so I just decided to put these aside for the preamps and cut a couple of boards to put the 2 channels on. I hope that makes sense. I was going to make 4 small boards for this, but I basically went with 2 bigger boards, and now I don't need to cut boards for the preamps. Although, to tell you the truth, I may end up still cutting boards. It depends. So it just depends on the preamp design. These boards will be alright for some designs. Other designs I'll need a little bit more width, so it just depends. But there is already 4 there. Anyway, I just wanted to mention that. So something else I've just noticed, I was just doing the top bit there where the capacitors, diodes and resistors are. That's wrong. It's supposed to be the other way around. Let me just show you what I mean. Pencil. Sorry. So, what I'm supposed to have is power coming in to a diode and then a resistor, and likewise here, resistor, diode. So they were just around the wrong way, but it's something I always like to do, is to do it in that order, because if there's any switching noise from these diodes, if you put the resistor in front, you've now got an RC in front of the diode. That's going to dampen it out a lot more than if the diode was there, right? Just food for thought. Anyway, I'll get this finished on my old workbench. Seemed to be replaced actually. Yeah, so I'm just working out, like I said, spacing. I've created more spacing. You can see I've moved them apart and down a bit, so I'll get everything to fit on there, and I've basically left about the size of 2 of these to each side of it, which is going to be plenty of room to fit 2 of them and a couple of 33k resistors and a couple of traces. It's basically going to look the same as that, you know. And I've got ample room now in the center here to put these components. I may still lay them out slightly differently, so I might put, say, you know, a diode and a resistor here and the 2 capacitors here, like that. They'll still be in parallel, they'll just be a slightly different trace layout. I can show you what I mean. So we're looking at those 4 components that are suspended between 2 points. So what I'm saying is I could basically do this. Brain's not thinking. Yeah. So it would sort of look, you get the point. Basically something like that, you know. Obviously it'd be a little bit neater than this, but I might not lay all 4 on top of each other. I might put them side by side, but either way I will be able to fit it there. I might even move, actually no, I can't move those down any further because I've got a trace and 2 diodes down the bottom, and I still want a gap between the end of the board and those 2 diodes and the trace. I don't want any traces coming to the edge of the board. So yeah, alright, that's the first board done. I'm not gonna lie, there was one thing that I forgot to lay out and I sort of just moved something around at the end to fit it. I might do it a bit different on the next board. So the, well, I'll just touch that. The diode that goes to the base of this transistor, it sits here, and then the wires that go off, the other diode goes there. The 2 wires that go off to the diode string for the bias network will solder here and here. For this transistor, I forgot to add it. So what I did was I brought this track down. It was just, originally it was going like this, and then I moved it down, and then I ended up moving in even more, and I've just added this blob and this blob here, so I can put a diode between here and stick a wire there and there, if that makes sense. It's not how I intended it to be, but it'll do. As you can see, the 2 power traces I made a little bit thicker because I just feel like it's a little bit of length. I want to keep the inductance down. All the traces are actually quite thick, but I made those thicker and the return to ground a bit thicker just to keep the inductance down there. What else can I say? That's it really. Nothing else to say. I might even thicken up the trace just, actually I don't want to rest my hand on the board, just a little bit more. Oh, that's the wrong Sharpie. That was an old Sharpie that's just for like marking stuff when I'm cutting. Just make it a little bit thicker. Yeah, that'll do. Just so, not for current again, just for inductance, so that these legs that go down to the bias network have got a nice short stub back to where the capacitors are. And, you know, if this thing's slamming each side on and off at, say, 20 hertz or something like that, you know, there's not much inductance there to produce voltage spikes. And the bias network, like I said, it's got this short little stub back to the capacitor, so I'll leave that like that. Good enough for Australia. So that's my board. I've got the spacers here. There's going to be a reverse diode, a resistor, and 2 capacitors. Yes, it will fit. The thing I realized when I was tossing up whether to put 2 side by side like that or do it all on top of each other was when I grabbed the 4.7 mic cap, I realized, hold on, it's a 4.7, not a 47. That's tiny. I can fit 4 electrolytics of those there, so that's fine. The biggest component, you can fit 4 of it in a row, so there's not going to be any problem fitting a diode, a resistor, one of those, and a film cap. So I'll go and check over this now, make sure there's no little nicks or anything in the black. So when I etch it, I get perfect traces, and we'll get to etching. All right, I've changed my mind. I was going to just thicken those traces up and etch it, but I've decided I'm going to do both of them at once. My thinking was, because on the output board I'd forgotten something, and because I'm likely to make changes to this thing, I was thinking about doing one, testing it, and then doing the other, but I think I'll just do that with the preamp boards, because like I said, I did have this amp built before and it did function, so I think I'm just going to go with it. So I'll get this board laid out as well, and then I'll etch both of them at the same time. Yeah. So I was just having a look at these things and the output board. It's in between this piece here, the width of it's about 1 mil, 1.1. With a 1 mil hole, it'll be a nice press fit. But that also got me thinking. I was trying to drill 0.6 mil holes, snapping bits, tried going to 0.8. I managed to do it, it wasn't fun. One's quite solid. I don't think I'm going to have a problem with one. I think I'm going to have another crack at drilling holes is where I'm going with this. I think maybe the bit that I had was like a cheaper bit than this. I'm saying before I ordered these bits, the bit that I was using to drill the holes before, when I had just the one bit that was a little bit too big. I think it was either 1 or 1.2 mil, but I think it was made of a lower tensile metal, because this feels way more solid. So I'll give it a go. I mean, I've already got to drill holes on the output board anyway, output boards. So I'll do them with these drill bits, and if I like the feel of it, I'll drill everything. If I don't, I'll just go back to this, which, you know, it works out. Hold on, my focus is locked. Right, you know, like, it is securely attached, everything's solid. The board looks a bit dusty because I still haven't cleaned that PCB cleaner residue off of it. That's why it looks like white and hazy, but you know, all the solder's nice and shiny, and it is strong. I've never had a problem soldering stuff to the top of boards like that. And if you think about it, I mean, what's SMD? How's half of everything made these days? Soldered to the top of a board, right? So it's not, there's nothing wrong with it. You can run into problems when you start using components that are this big and they've got weight to them, because they want to wiggle around, and then you can bend leads, create crease points, fracture solder joints, you know what I mean? But most of the components, or sorry, all the components on these boards are really small, so yeah, I'll see, but we might end up drilling holes. If I do drill holes, it will look a lot better, because this will be face down, so you won't see any of my hand drawn traces. You'll just see what looks like a normal PCB. Actually, that doesn't really look too good either, because I cut this with a Stanley knife and snapped it. Yeah. I'm not really fussed either way, but I'm going to give it a go. I hope this isn't getting confusing, me jumping between two different things, but I was just having a look at a couple of these boards next to each other, and I just realised again, because I've got all the PNP on one side and the NPN on the other side, actually these two resistors need to go between the two boards, which makes it just a little bit more complicated. Actually, you know what? That might actually make it easier for me, because the boards are going to have a little bit of a space in between them. If I put... Maybe if I put one standoff there and one standoff there, I can string my two resistors in the middle and then just run a wire from the standoff to the base pin. No, I've come against it again, haven't I? I need 4 resistors, 2 in series, times 2. Oh man. It's the worst when you forget traces or pads, because I've not left any extra room. So now I have to try and fit 4 resistors where there's no room. I'm going to pause the video and have a think about this. Alright, I've got it. I know what I'm going to do. We are going to have to make use of the smallest little bit of space that we can use. So I'm going to have to drill I want to say one hole there and one hole there, but then on this side it's going to be a little bit more odd. It's going to be one there, You know what? If I put these things sideways, I could fit it here. I could. I can always take my Dremel and Dremel, you know, 1/2 mil of copper away from here and here to open this space up a little bit more too. So I've still got my space between everything. I think that's what I'm going to do. I mean, I could put it there, I guess. One resistor will go like that and the other one will go straight. I guess that won't look too bad. Electrically it's better because I have more spacing around everything, you know. I think that's what I'm going to do. Yeah. And then I've only got to put 4 standoffs, 2 on each board. Well, that actually means 8 in total because there's 4 boards, but it's better than 3 on each board, isn't it? All right, I'll go do this and I'll come back. I swear I had 6 of these. I'm always losing little things in here, and I never seem to find them. Oh well. Alright, this is what I came out with. I tried mounting those things in the holes. I was right when I said 1.1 mil, because 1 mil I couldn't squeeze it through the hole even with pliers, and 1.2 mil it just fell through the hole. So I just drilled 1.2 mil holes and I decided we're just going to, I'll show you. These resistors are quite long and it's 2 in series, so it's going to be like that long. I'm just going to wrap the resistors through the holes, like so. Maybe, yeah, we'll go through the top like that. And, you know, I'll just solder a wire over to the side of it here that goes to the appropriate base pin. That will leave a fairly decent spacing too, electrically speaking, between the closest pad and that resistor leg. So not what I wanted, but at least it's a solution. You know, the resistors are there. these boards back over there. Alright. Alright, I'm going to get this finished now. And then etch these two boards up. Oh, also, I've drilled 1mm holes and 1.2mm holes with these bits. And I've got to say, 1mm, I'm happy with it. I'm going to drill holes. I'm going to drill holes for everything. So, I think where I've met my match with making boards is surface mount. If I've got to drill a whole load of 0.6 and 0.8mm holes, I need a drill press. You know, something that's CNC would be even better. You know, I can't think, is that the term for it? You know, like an automatically controlled drill press that's computer controlled. Anyhow, I guess what I'm going to do in the future, when I've got to do SMD boards, I'll design them using CAD software, get it done through a PCB manufacturer. But when I'm doing through hole, I'll do it myself. That is until I get, say, you know, a little CNC machine or a laser printer and some of that, I can't think of the stuff, the iron-on PCBs. You can print essentially an overlay of your traces. You still etch the board. It's just another way of doing it instead of drawing it with marker. But until I get a proper setup like that, I think I'll start getting SMD stuff done at a factory, and I'll just do these boards by hand, because that was an absolute, you know what, trying to get that SMD board done the other day. I just spotted something wrong with this board. Where the resistors go here, there's also supposed to be a pad coming off the emitter pin to connect to the bases of the following stage, and I completely forgot about it. So, wait, don't tell me I forgot about it on the top two. I did too. Wow. What was I thinking? The rest of the amplifier is just going to drive itself. No, that's not how that works. All right, so emitter, 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 emitter. All right, that's a bit better. Moving on. What happened is I was doing the emitters on this board, and then I came down here and I was thinking, okay, where am I going to put my I thought I did that wrong for a second. No, I didn't. I was thinking, where am I going to put my emitter resistors? And I glanced over to the other board. Sorry, not the resistors, the pads. I glanced over to the other board, and that's when I realised they weren't there. So, anyway, that's resolved. I'm having the worst day today. You know what I've just realised? I haven't put the bloody diodes and resistors on this board either for the power rails. Ah, goodness me. Well, I guess we can just put one resistor there, or one end of one resistor there. So what I'll do is I'll just put a pad there, and the same on the other side. And then that will have to go to another pad. Man, this is not good me forgetting things. Let's make that pad a double length pad. So I can essentially put a resistor and the diode leg onto the one pad, because that's the only way I see myself getting out of this. Alright, so I can put my resistor from there to there, and then my diode from there. I guess we'll have to do the same thing here, another little rectangle, which will be basically our power wire and our diode on that pad. Really made a mess of this. That's not that bad. It looks messy, but electrically speaking, there's more than enough space here. I mean, this is, if you went and got this board commercially done, there's no way the traces would be this big, you know. This is because I've done it. So, you know, there's gaps between traces and the traces are bigger. It's not, no problem. I'm going to be a perfectionist and just take this one trace down just a little bit, just so there's good clearance between the power rail. Oh, I guess that is the power rail. What am I doing? Oh well, it's done now. Jeez. Now I'll just thicken this back up again. Yeah, that's good enough. All right. Oh, I scratched out that. Now we're good. I wonder what else I've forgotten off of here. I wouldn't be surprised, knowing me. All right, back to this. So I might do the same thing on this board, but because I'm doing it now, it's going to give me the advantage of routing it a little bit better so that, you know, I can make these pads a bit longer. I mean, that one's long enough, but that one's a little bit close, you know. You know what? I could move that up, and you know what? It's all good. One thing I've got to remember is I'm going to be drilling holes. So, you know, I can have things a little bit to the end of a track or two component holes a bit close together in terms of looking at it from this side, but it can still look good from this side. So, yeah, it's all right. It's not the end of the world. I think I just try and shoot for the stars too much. I need to just be more happy with less. All right, so that's what I've come out with, and that's what I'm going with. I know it's not the most beautiful thing in the world, but I don't think it looks that bad. So, I mean, yeah, I could use a ruler and make it all straight, but as I pointed out before, that makes a mess, and I have to clean up the mess, and it takes forever. I don't mind this. You know, I mean, in one way you could say it looks a little bit messy because it's hand-drawn, but at the other time, in another fashion, you could look at it and say it's cool because someone's taken their time to draw it by hand. So it's, I don't know, it depends how you look at it. Look, in my mind, as long as it's not ridiculously messy, the thing that's most important to me is that it's electrically sound, you know. Traces are thick enough, spaces between traces, you know, inductance, all that sort of stuff. All that criteria is right. I'm usually pretty happy. So I'm going to etch these boards as they are now. So yes, one is slightly different to the other. So let's see. Let me get something to point with. On this board, our what do you call it? Wait, have I drawn this around the wrong way? Oh no, that's the base, yeah. On this board, the base diode that goes... You know what? I have forgotten something. On both boards. Oh, goodness. I know exactly why I've done this too. I've forgotten to put a pad... Oh my god, what are these cats doing? Hey, what are you doing? Get out of there. Come on. Out. Out. Come on. Out. Thank you. I've forgotten to add pads to each base to connect a wire to each base for the drive. I know exactly why I've done that because... Actually, I won't use a texter. Originally, on my heatsink where I had the diode string, let's just pretend this is the heatsink. you know, I'd have my diode string like this, and in the center of the heatsink I had the resistors. Hope that makes sense. So that one's a pot, 120, 120, 560, 500 pot, and the diodes. And what I had done is where these 220s are, I had soldered a wire onto there, and that's where I was injecting the signal in. Now it's just come to my attention laying it out on boards that, well, for one, I want to try different preamps. Some of them are AC coupled through a capacitor, so that will tie into the center point on the bias board. You know what? Let me go grab that. That's something else I didn't think of when I laid that out. I didn't leave somewhere on this board. Actually, you know what? There is a couple of center points on this board, because there's going to be the two resistors. Yeah, so these two traces in the middle. Yeah, there'll be a spot on there I can solder a wire onto if I have to, so that's all right. That works out like the output board does, in the sense that because the traces are so big and wide, you can just add things to it. This board, it's a little bit smaller, so I am going to add the extra pads. I'm going to have to think about this carefully because I'm running out of space. I think I'll pause the video and have a think about this. Alright, that's that problem solved. What I've done, because I want these connections really close to the bases, so the transistors, 3 pins there, 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 and there, and for this board, oh sorry, no, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the base is the middle pin, so I've put a pad there, right next to the base, pad there, right next to the base, same thing there, same thing there. And on this board I've done the same thing down the bottom, but up the top here, because this space is taken up, oh no, sorry, that's not the pad, that's the pad. On this board I've put the pads there because there was space there. On this board, because there's already a diode here, I've put the pad here, but it's still what, you know, right next to the base pin basically. So we've got base pads now. All right, now the boards aren't missing anything. So now I can etch them up. I still am going to have one more look over it just to make sure, because I've missed that many things today. I'm certainly not having a good board layout day today. So I'll have a really good, careful look over this before I etch it, but that's what I'm going to do now. Have one more check over it and then get to etching. All right. How's this for luck? You can't make this up. I mean, they just fit in there. I do not need to scratch my ink off. Come on. Don't do me like this. Alright. I'll go warm up a bit of ferric chloride, stick this heat plate under here, and we'll etch this up. Alright. Cool. Now we wait. get those boards into the center because the heat's going to be mainly under the center. There we go. Magic. No, you guys couldn't even see that. Thought I was showing off my skills there. I was going to use the big bath that I've done the batch of boards in that's almost used up, but I'm impatient and I've still got at least half a bottle here. Oh, yeah, just under. Plus whatever's left of that. So, you know, about half a bottle worth of ferric chloride. So I'll definitely be able to get the rest of the boards done for this amp, and I'll probably still have some left over. Tell you what, I'll let this go for a bit. Let's get my fume extractor going. There we go. I'll come back in a bit. Alright, so while this is happening, there's a couple of things I wanted to talk about. One, something just came to mind that I was actually meaning to add to these two boards, but it's okay because that I will be able to just drill an extra couple of holes. I wanted to put a position to put a capacitor. It's called a suck out capacitor. The resistors that you have across the bases, another technique is to put a capacitor in between the bases to help suck the charge out of the bases to get them to turn off quicker on both sides. So I wanted to put, I'm just going to drill a couple of holes at those two nodes and those two nodes on the board so that I can stick, say, I don't know, like 100 nano and 10 nano or something like that, you know. Now, the big thing I wanted to talk about, I've been thinking about how to get the price down for this. Let me go get the heatsink. One of the heatsinks. And then I'll go get something else because that's what's on there. And the reason I've done this is because with the big metal tab and that little piece of mica, the thermal coupling is amazing. However, BY229s are expensive. Now, I've been thinking about using transistors as diodes. You know, I'm sure everyone knows how to tie the base junction and collector and use it as a, what do you call? I forget the name of it. I've gone blank. But you know what I mean when you use a transistor as a diode. Now, I've noticed with TA126 devices, some of the packages actually have a little bit of metal on the back. Let me go get a couple of devices. I'll show you what I mean. When I say some, I mean a lot. I mean, just in these two drawers, in this drawer, we've got D882 and B772s. In this drawer, there's BD137, BD139, BD140. They've all got metal backs. I could take a whole load of D882s, for example. These are a cheap general purpose transistor, cheapest chips. I could use these, I'm thinking, as diodes. So that's something I'm going to experiment with in the future with this amp build. But I just wanted to point that out. For anyone that wants to build an amp like this with the diode string temperature sensing, but they don't want to fork out all that money on BY229 diodes, well, look into TA126 devices with a heat spreader on the back is what I'm thinking. The reason I've gone with TA126 is because it's, you know, the smallest device after a TA92 that's actually got a heat spreader on it that I can think of anyway. You could use a TA220 device as well, but it's going to cost you more money. You can find some really cheap devices in TA126 packages. Let me just go get the tweezers. I want to have a look at how this board's going. Alright, you're making progress. I'm just going to give it a bit of a move around. It's starting to warm up now, so I want to spread the warmth around. And now it's going to start etching quicker. I want to keep it agitated anyway. So that's what we're going to do as one of the experiments on this amp, other than just experimenting with different ways of getting the transistors to turn off quicker, getting both sides as linear with each other as possible, you know, low distortion figures, all that sort of stuff, trying to measure phase margin and, you know, getting it up to where it should be. I think the minimum you aim for is around 45 degrees, and it's better if you're around like 65, 80, I can't remember. But, you know, there's a few things I want to look into and play around with, not just front ends and diode strings. So, all right, I'll leave this and I'll come back in a bit. And yeah, if anyone is wondering, I am basically making this up as a kit. That's what I like to do. If I've got enough idea of how I'm going to build something, or the whole plan preferably, I'd like to get all my components, put them aside ready. All the little ones are in a bag so they don't go anywhere, all the big ones are over there. You know, get all my boards made up, and then I can just sit down and just assemble the entire thing. You know, I can just spend a day assembling boards, for example, put it all together and turn it on, you know. That's just the way I like to do it. So that's what I'm doing. All right, it's come up to temperature and I've turned the heat plate off for a bit, just so I don't get the tray too hot, and also so I don't get the solution too hot. When it starts to cool down, I'll turn it back on. But I'll just give you a look at the edge of the boards. You'll notice that the copper's turning pink and starting to disappear, starting at the edges, which is how this goes. I'll just leave that for a bit and we'll come take another look soon. Something else I wanted to talk about, it relates to the output boards. Now, I've noticed in a lot of PA equipment in the Zabel network where the R and the C is not the R and L, the R and C that's in series with each other from the output to ground. I've noticed that a lot of PA amps, I've seen two 100 nano caps in series, or sometimes two 220s, which is what I would do in series, because you're only left with 100 nano and twice the ESR when you do that. And I can tell you why. It's because of reliability. And, you know, for one, if one cap fails short, the other one's still open. And secondly, the likelihood of them failing short is a lot less with two in series, because the power dissipation's halved across the two capacitors. Now, I thought this was only done in PA equipment, but I was just looking down here on the floor at this home theater receiver board that's in my scrap bin. Yeah, they've done exactly what I'm talking about. These are all 224s, and these are the type of capacitor that I would use too. So what I'm actually thinking of doing is nicking them, because when I chose the capacitors, I had a lot of options. Let me go get some examples. But I mean, even in this bag, I've got an example to show you. So even when just picking 100s, look at the size difference between 100 volt 100 nano mylar and a 250 volt. The 250s are the ones I chose for the snubbers. So obviously that can handle a lot more ripple current. Now, if we take a look at these, they're even bigger. And they are 3F, so that's, I think that's 250 or 400 volts that they're rated for. I forget what 3F is. I could look it up, but I can tell you now it's at least 250 volts. Like 2E is 200, I think. So I might be wrong, it could be 100. I might be written on some of these caps actually, hold on. I'd have to go and look through the drawers otherwise to give you a definitive answer. Yeah, I'll have to go have a quick look. One moment. Alright, well I found out that 2E, just from looking at a capacitor, is 250 volts. So 3E is at least more than 250. So I'm going to do that. I'm going to take, let me think about this. How many do I need? I need 8. Because what I want to do, these are 224s. I don't know. Honestly, I don't know if I want to do this or not. I think I do. But here's the reason I don't. With 2 caps in series, it's double the ESR. So, yeah, I'm really tossing this one up. I think I'll leave it for now and I'll sit on it, on the thought, you know. I'll have a think about it over the next couple of days and whatever, however long, day or two until I actually build this thing. And, you know, I'll work it out then. I just don't want to rush, you know. But after seeing this board, I think what I'm going to do is have a quick look at some schematics that I've got on my computer. If I've ever been confused looking at schematic, I'm confused now. I've just got a load of different schematics up. If you see the top of my screen, all those tabs. Anyway, this is the AMX 512SC mixer that I'm in the process of repairing. Now, here's the inductor and resistor, but look at this. They've put a network either side of it, but this is what intrigues me. The network on this side has got 2 capacitors in series with the resistor, but if we come down to the amplifier section, there's also, wait, oh, that's the power rail I was looking at. Never mind. I just saw this little snubber down here and I didn't realize I was looking. Yeah, that's not the power rail. Wait a minute. Oh, that's not the output, but okay. Yeah, so no, that is how they've done it. Okay, so I was right. There's 2 in series. Whoops. But then there's one little network afterwards. I'm not worried about that. But I don't agree with that. 0.1 and 0.1 in series. The ESR on a 0.1 is going to be double what a 0.2 is. And then to put 2 of them in series, jeez. I don't really agree with that. Here's an old PA amplifier that I used to own. Soundtech PL1000MP. Coincidentally, where those heat sinks came from. Okay. Just 1 capacitor and 1 resistor. Hey, they chose the same values as me. I would imagine that's a pretty universally chosen figure, but yeah, 4.7 there too. I like this. I'll tell you something that surprises me. Well, it doesn't actually surprise me at all. Whenever I look at old schematics, things that were made in the 90s usually, or earlier, I usually agree with what I see. And when I look at newer stuff, everywhere I look, I'm just like, oh, that's not very good. That's not very good. That's not very good. You know? I don't agree with that. I really don't. I'm going to say that, you know, that has got a higher risk of failure, but it's going to do a better job. I would meet in the middle and increase the value of this to 224 and put 2 of them in series and maybe decrease the resistor to say 33 ohms to compensate for the increased ESR. You know? But that's just me. Anyway, what do they use for base resistors? No base resistors there. 150 there. So 300 ohms between the driver emitters. The reason I'm interested is because this thing was 250 watts into 4 ohms aside, which is what I'm building. So, and I know the whole thing's, it's not all Darlingtons, but the output stage is a Darlington. So I was just having a quick look at it. Anyway, here's another one. This is a Yamaha AX700. And over here at the output, we have a 10 ohm resistor, a 1.5 microhenry inductor. We're over here, they've put it on this side. So, okay, that's interesting. Wait. Why is there a capacitor across speaker A, but speaker B? Oh, okay, I see what they've done. So each output's got a capacitor across it, but the actual snubber networks for each of the two channels are there. Okay, that makes a bit more sense. So, wonder what values they chose. Let's have a look. This thing could do about 250 watts a channel. Let's see. R402C358. Oh, I don't have the parts on this. Damn. Alright. Well, there's no other schematics on here. Everything else I've got on here at the moment is just small, little things. Nothing big. This is all I was able to find that's actually locally on my computer. So that still sheds a little bit of insight. I mean, I guess some people are doing it one way, other people are doing it the other way. I think, saying that, I think for now what I'll do is I'll leave it with these 250 volt polys. But when I run the amp, we're going to have a look at it and see, you know, if the capacitor is getting warm or something like that, which I can't see it doing unless the amp's got some sort of high frequency oscillation, but I don't know. I've got to look into this subject a bit more. Maybe every time that network goes to dampen an oscillation as it starts, the higher frequency of that happening is going to mean more power being dissipated in it, so it could warm up. So I'll have to have a look into that, and I'll do a bit more research. I already have done quite a bit of research, and I tell you what, I did a lot of reading, and I've come to the same conclusion as what I just came to now. Some people do it one way, others do it another way. And I don't like that when I find that sort of an answer, because I like to have a definitive answer as to why, not just, you know, this company likes to do it this way, this company likes to do it this way. I want to know what's the better way of doing it. So, excuse me, I was just getting a drink. Let's see. These are actually done. Oh no, almost. Maybe another 5 or 10 minutes. Tell you what, I swear this second bottle's been slower than the first bottle. It is pre-mixed, so there's quite a high likelihood that one is stronger than the other one. I mean, it shouldn't be like that, but it seems like it is. And I'm heating this, so it's not a temperature thing. If I wasn't heating it, I'd say, well, yeah, it's bloody cold at the moment, you know. But no, I'm just turning the hot plate back on now, but it's still warm. I haven't let it come down from temperature, so. Hey, get out of there. The cat's going behind the TV screen. Let go. Jesus. You can't go behind there. No, sorry. You certainly can't come up here. Holy shit. Dude, don't scare me like that. I've got a cable going to a hot plate and I've got ferric chloride on it. You can't be here. This cat's scaring me. Oh my god. No. Alright, you've got to leave. You're being very dangerous. Sorry. Sorry about that, guys. I've got this cable that's powering the hot plate just here. It's hanging over the edge of the table, and the cat was trying to climb up and it's putting its paws on the cable. This entire thing could just go, you know, on top of the cat. Wouldn't be good. That's odd. It looks like one board's completely done almost and the other one hasn't. Still a bit on it. Yeah, they're fairly even. I think there is a little bit more on the right one, but it's alright. I'll pause the video and I'll come back in a bit because this is honestly taking way longer than usual. I thought this was going to be quick. I mean, I just put a fresh solution in here and I've got the heat going too, so strange. I shall return. I just walked back in here and I was looking at the AX700 Yamaha schematic and this made me laugh. I've got to do this. Do you reckon the drivers have got enough drivers? No, I'm just kidding, but that is quite packed. So there's your input section, and it's nice and broken down. I like it. You know, the only thing I don't like about this schematic is the size of the font and sort of the way it's laid out. It makes it very hard to read. They've crammed a lot of information in here, but which is good. So, you know, if you take the time, it's worth it. Like, look at this, 61.9. The voltage is written there. You've got arrows for the signal path. You've got these little boxes here that show you that that's a... Let's go look at the legend. So there's all your different capacitor types, your different resistor types. And like, this is the thing. You don't see this anymore. I mean, this is something I actually put some thought into with this amp that I'm building myself. You know, using carbon film resistors in some places that I don't want metal film or metal oxide, you know. Same with the capacitors, the choice of capacitor. You look at stuff these days and it's all just done as cheap as they can do it in a lot of cases, unless you pay a ridiculous price anyway. But, you know, back in these days, this was the way it was done, properly. I mean, look at all the different types they've got. That's just wonderful. What on earth is a semiconductive ceramic capacitor? I don't even know what that is. It could just be some term for something that I'm not thinking of, like a tantalum or something like that, you know. But I don't think it is. I'll have to look that up. But I mean, that's beautiful. There is what? 1, 2, 3, 4, 5, 6, 7, 8 different types of resistor. Let that sink in for a minute. 8. I mean, that's something. In my opinion, to sit down and take the time, you know, to come up with 8 different types of just resistor for your amplifier. It shows me that you're putting effort in, you know. This is a project that I've got coming up in the future. I've still got this. When I was younger, I went and put bigger transistors in the output section and a bigger rectifier and a bigger cat bank in it. And yeah, that went fine. And then I decided to take it one step further and change the drivers. And yeah, I ended up letting the smoke out of it. I've still got it and I want to put it back fairly stock. With my knowledge these days, I could probably, you know, make it a little bit better than what it was. Probably go back to the first mods I did on it and do a better job of those, if that makes sense. You know, but I want to put it almost back to factory and get it working again. So that's something that we'll do eventually. I've got a lot of different things to do. I'm just trying to get through a lot of projects, things that I've got that I want and have to build. I want to get finished, like my amplifiers, little projects in the lab, power supplies, microamp power supplies, small amplifiers for signals and stuff like that, like high frequency stuff. You know, I want to get all those things done before I start tackling a whole load of repairs that I've got. But man, I have so many repairs. Like, I've got a lot of stuff to fix. I mean, we're talking probably 10, 15 things that are just listed waiting for me to do. Oh no, my ink's coming off. Oh no. Oh no. It seems too much heat's a problem. I'm gonna have to take these boards out quickly, dry them up, wash them, dry them, and redo some ink. I'll be back in a minute. Well, I don't know whether to be pissed off or happy. That was an optical illusion. Yeah. The ink didn't come off. We're good. Go figure. I just wasted some time. But you know what? I can't complain because I didn't have to muck around redoing the ink. So that was actually good. Alright, well, not quite sure what on earth happened there. Now I can see the ink. You know what must have happened? Copper deposits must have been on the track and it glistened in the light and I thought I was looking at copper. But no. I was quite surprised because everything's clean here and it's a fresh solution and this stuff works really well. Like that ammonium persulfate that I used to use, that's terrible stuff. But this is great. When I say great, I mean, well, as a product, but for not lifting the marker. I am absolutely lost for words. You know, this is a fresh bottle. I have not done any etches out of this. And it was coming up to 3 o'clock in the morning when I started this. I looked at the time and said, it's going to take 20 minutes. I'll use the heater. I'm going straight to bed afterwards. It's 3:54 now and we're just coming up on finish. This is a joke. If I knew this was going to happen, I'll tell you, I would have gone to bed. I would have done this in the morning. Oh well. It's almost done. I just had a little sneak peek about a minute or two ago. I hope I'm not confusing people when I say stuff like that. See, this is a series of video segments that I spliced together, so the camera wasn't recording. Just gonna put that board over the heat. That board seems to be going slower than the other board, so try and get some heat over there. I think I've got it all. Gotta be so careful I don't get that over the edge. Yeah, that's got it all. Alright, I'll just leave it for like another 30 seconds just in case there is a little bit more. I don't want to have to come back in here again. But I'll turn this board heater off. Ow, that's hot. Who would have thought? Alright, I'll be back in a minute. Alright, let's get these cleaned up and I'm going to bed. I'll have to splice this video together and upload it in the morning because I certainly ain't staying up for another hour or two now. I can better keep my eyes open. That's a lot of black. Nice copper. I love the look of copper. Not when it's oxidized, but when it's like this. Alright, we have 2 boards. I'll get up in the morning, I'll upload this video and I'll drill the holes on these boards, the other boards, and we'll start building the power supply in the output stage and these boards up, put it all together. Because as soon as that's done, well, I guess that's my goal for tomorrow. I'll get this video uploaded and then I'll get basically from this to the output stage put together and the power supply put together, and then the next day we can start doing the preamp. Fun. Alright, that's all I've got for now, so I'll see you all soon. If you like what you're seeing, please give me a like and a sub. Thanks for watching.